Welcome to ScienceCover.com. In this session, we will look at uses of radiation. We'll focus on smoke alarms and how we can measure the thickness of materials, look at how radiation is used to date the age of objects, and look at how radiation can be used for both body scanners and cancer therapy. First, pause the video and try the Do Now task. Let's check our answers to the Do Now task. First, we start with carbon-14 with 6 protons. It's going to alpha decay, which means that it loses 4 from the mass number and 2 from the atomic number. This leaves us beryllium with 10 as a mass number and 4 as an atomic number. Polonium 209 and 84 will become astatine 209 and 85, and the beta particle given off should have a 0 as the mass number and -1 as the atomic number. Actinium 227 has 89 as a proton number. We've got 227 as the mass number for thorium and 90 as the atomic number for thorium. And again, we're losing a beta particle here with a mass number of 0 and an atomic number of -1. And finally, we've got radium 226 and 88 as the atomic number, and that's going to decay to form radon, which has 222 as its mass number and 86 as its atomic number, and that will give off an alpha particle. So an alpha particle has a mass number of 4 and an atomic number of 2. Now let's move on to look at the uses of radiation. We'll focus in this section on smoke alarms and how to measure the thickness of different materials. First, let's look at how a smoke alarm works. So a smoke alarm has a device inside it called an ionization chamber. Now this is basically a radioactive source at the center surrounded by a detector, and the detector's job is to detect ionized air or charged air, and the radioactive substance will charge the air. It ionizes the air. So as long as this is present, the detector does not sound an alarm. Now the radioactive source that we tend to use in smoke alarms is americium-241. It's an alpha emitting source, and alpha particles can only travel a few centimeters, so it'll be able to get to the detector, but it's unlikely to travel any further or be able to get through the plastic of the smoke alarm, so it's not going to cause harm to the people in the household. But this alpha radiation will ionize the air close to the detector, and so the detector, as I say, will detect that ionized air and not trigger the alarm. If smoke enters the alarm, however, then it blocks the alpha radiation from ionizing the air, and that means that the detector can't detect any ionized air anymore, and this triggers the alarm. Let's have a look at this process in action. So we've got here our radioactive source marked at the center of the ionization chamber, and you can see the detector around the outside, and between the radioactive source and the detector is our air particles. Now the radioactive source will give off alpha radiation, which will travel out and strike the air particles. Now this means that the air particles become charged, and that's what we call ionized air. So as long as this ionized air is present, then the detector will detect that and it won't sound the alarm. However, if smoke enters the alarm, then the alpha particles can't reach the air. So the air doesn't become ionized, it just stays as regular air, and then the detector, because it doesn't detect any ionized air, will now sound an alarm. So the smoke stops the air from becoming ionized, and this is detected by the detector, which then triggers the alarm. We can also use radiation to monitor and maintain the thickness of materials. Many metals are pressed into sheets by rollers, and we can monitor the thickness of these plates by placing a beta radiation source on one side of the plate and a Geiger tube, which is a type of detector, on the other side of the plate. Now, the reason that we use beta radiation is because alpha radiation wouldn't pass through the metal plating, and gamma radiation would all pass through the metal plating, but beta radiation, the amount we will detect will depend on the thickness of the metal that it's passing through. So we can set up a computer to alter the roller spacing depending on how much radiation is detected. So if the plate is getting thicker, then it means that less radiation will reach the detector, so the computer can instruct the rollers to move closer together. But if the plate is getting too thin, then more radiation will be reaching the detector, so the computer can instruct the rollers to move further apart. Pause the video and complete task 1. Let's check the answers to task 1. Which radioactive element is used in smoke alarms? That would be alpha radiation. The radiation ionizes the air. What does this mean? It means that electrons are knocked off the oxygen and nitrogen atoms, which leaves them charged. Explain how smoke will cause the alarm to sound. Smoke prevents the radiation from ionizing the air, and the detector will detect a lack of ionized air, and so an alarm will sound. Question 4. This diagram shows aluminium being compressed into sheets. What type of radiation should be used as a source? Beta radiation. Why? Alpha radiation will not pass through the aluminium, and gamma radiation will all pass through the aluminium. So the amount of beta radiation passing through the aluminium will depend on the thickness of the plate. Explain how a computer can use the setup in question 4 to monitor and adjust the thickness of aluminium. If too much beta is passing into the Geiger tube, then the aluminium must be too thin, so the rollers move further apart. But if too little beta is passing into the Geiger tube, then it means the aluminium is too thick, so then the rollers pinch closer together. Now let's look at how we can use radiation to date the age of organic material. Living organisms contain carbon. There are two types of carbon, carbon-12 and carbon-14. The carbon-12 is stable and not radioactive. However, carbon-14 is radioactive. A very small percentage of the carbon that an organism is made up from is made out of carbon-14. But as the organism digests materials, they replenish this amount of carbon-14, so it roughly stays the same percentage throughout the organism's lifetime. However, after death, the carbon-14 is not replenished, and so it decays. This means that the amount of carbon-14 will become less and less over time. We can therefore look at what percentage is left and use this to estimate how old the organism is. Now, this process is called carbon dating. Pause the video and try task 2. Let's have a look at the answers to task 2. What's the difference between carbon-12 and carbon-14? Well, carbon-14 will have 2 more neutrons than carbon-12 has, but also carbon-12 is stable, whereas carbon-14 is radioactive. Explain how carbon-14 can be used to estimate the age of the bones of an organism. The carbon-14 is replenished throughout the organism's life and stays at roughly the same amount. Once an organism dies, the amount decays and decreases. By studying how much carbon-14 is present, the age of the organism can be estimated. Now let's look how we can use radiation as a body scanner. We know that radiation can be harmful. However, all operations involve risk. And so being able to perform a scan and see inside the body without having to operate or cut into a patient actually reduces the risk to the patient. So despite the fact that radioactive substances could be dangerous, they do reduce the risk for the need of an operation. An example of this is using iodine to check if a patient's kidneys are blocked. So the doctor will give the patient iodine tablets, and this will end up in their bloodstream, and this radioactive substance will flow into and out of a healthy kidney. However, if the kidneys are blocked, then we know that the radioactive substance will run into the kidney but won't run out of the kidney, and so we see on a scan a build-up of the radioactive material at the kidneys. Now, when a doctor is thinking about what kind of source they should use, there's three properties that they need to consider. The first is that the source should have a short half-life. This is because they do not want the source to remain radioactive for a large amount of time. Usually just a few hours will be sufficient. We want something with a low ionization. This means that it's got less chance of damaging the cells or causing cancers. And we want something that's highly penetrating so that it passes out of the body and allows the doctors to perform their scan. Now, gamma radiation ticks a lot of these boxes. It's low ionizing and high penetration, so it's often chosen as the source. Pause the video and complete task 3. Let's check our answers. Why is it preferable to use a radioactive source rather than operate to investigate the problem? It's lower risk to the patient. Why is gamma radiation often used rather than alpha or beta? Gamma is less ionizing and it's also more penetrating. Explain how iodine is used to check for blockages in the kidneys. Iodine will pass into and out of the kidney. If there is a blocked kidney, the source will not leave, and so this can be detected with a gamma camera. Why is a source that has a short half-life selected? This is so that the source is not radioactive for a long time, and that reduces the risk to the patient. People are often given information leaflets explaining they should flush the toilet several times after use. Why is this? Their waste will have radioactive source inside it, and this will contaminate the toilet water. And flushing the water will replace the water with non-contaminated water. Now let's look at how radiation is used in cancer therapies. All cells produce copies of themselves. But if there is a mistake in the DNA of the cell, then this will be copied too. This is what we call a cancerous cell, a cell producing copies of itself when it has incorrect DNA. If the cell is multiplying out of control, then it's what we know as a tumour. The best way we currently have of stopping these cells multiplying is to destroy them or kill them. To do this, we expose them to high-energy radiation from gamma rays or X-rays. We call this radiotherapy. The advantage of radiotherapy is that it kills the cancerous cells. But the disadvantage is that it could cause damage or cancer in healthy cells. The patient will experience a loss of hair and will also feel unwell. Now pause the video and try task 4. Let's check our answers to task 4. What is a cancerous cell? It is a cell with errors in the DNA that is producing copies of itself. What type of radiation is used in radiotherapy? Gamma rays and X-rays. Should radiotherapy always be used to treat cancers? Compare the advantages and disadvantages and form a conclusion. Well, the advantages is that we know that the radiotherapy kills the cancerous cells, but the disadvantage is that it can cause cancer, it can cause hair loss, and it can cause the patient to feel unwell. So generally, radiotherapy should only be used if the cancerous cell is causing a high risk. This means that it's placing the patient's life in danger. This is because the treatment itself carries the risk of causing other cancers.